And Andy, it's all yours.
All right. Well, thanks again, everyone. It's been a little while since we've done one of these webinars, and definitely was time. I apologize that it was on a Friday, but trying to find a good time to do it. It's been, I will say, the last several weeks have been quite the flurry of busyness. Between there's, a lot of you know that there's roadmap work going on for Central Region that we've kind of been involved with, and then the forecast for the forecast builder and the grid team as a whole, we were generating a report, and so we finally get through that, get back to doing the webinar. So for today, for the topics, we'll go into some of the preliminary results from that experiment, or from the experiment, as well as the future plans for the forecast builder itself. It feels, for some reason, it feels like a while ago to me, but that heavy rain and snow event for April 28th through the May 1st that we were dealing with. A little bit of science, news, and tech stuff. Talk a little bit on HazardBuilder and model certainty, and then open it up. So for the experiment, actually, it was a really cool report that we produced. Hopefully, it'll be shared around. But in the experiment, there were quite a few findings. I mean, it was a big experiment. A lot of things going on between the, both leveraging a common starting point from the, from period, what we started at of period 2, move to period 3, using the same procedure to do snow and ice, and then for a lot of the region, end up being the same procedure for weather. So I'll kind of run down through some of the findings here in these next couple slides and show you a few images along the way. So the first one here this is definitely true across the board, that having this quality common starting point was effective for all the grids starting again at period 3. We first started at period 2, but definitely period 3, and I'll show you some consistency stats here in a little bit. Having that set time, for the common starting point is effective. Everybody knows when the grids are going to populate. But again, we had to do some adjustments here lately to handle the ISC issues, kind of more of a technical problem. But it looks like I haven't heard many issues in that regard, so I think we've got a lot of that fixed. Definitely forecast builder beneficial, organizing and standardizing forecast process. Definitely result in much more consistent snow and ice grids. I'll show you that as well. And then we had sound science employed to get the snow ice accumulation weather. A lot of positive feedback, I think, on the FRAM that's being used for the ice accumulation. There were some times where it may have went a little, maybe a little too high. I mean, but hey, not bad for giving us a first start for ice accumulation. And I mean, this was at least the premier ice accumulation event in terms of maximum ice accumulation across the entire winter. I know that the winter wasn't, a big winter by all means, but hey, we got a big, this ice event, which the current process for P-type production, the FRAM, this is what it's supposed to work. This is what it's supposed to be good at. And I looked at Wichita's website, a nice little ice analysis. I know one thing to be actually nice is that we have a national ice accumulation observation thing, very similar like the NORIS does for snow, but that unfortunately doesn't exist. Some other ones, from most of the time, snow ice weather grids were no longer hand edited. And actually, for the test bed offices, that was no longer the case. And they're just derived out, which helped keep the internal accuracy and integrity. We mentioned the common starting point. Our verification scores did not suffer, and also showed marked improvement over the previous forecast. When there's been I saw some verification slides that, the previous is just over both statistics is just not good. It's just not good. You have to keep that. You have to keep having new model guidance flowing into your forecast. Collaboration, can be more effective. I think having that common starting point. talking about consistency, so I inquired with Dave Ruth, who handles a lot of the NDFD stuff at the MDL level, and asked for some consistency stats, and took a look, grabbed them for each region and for the whole entire time period there for the experiment, October through March. So again, this is the entire region, not just the test beds. So I think this is actually pretty remarkable. It'd be neat to just do one for the test beds, which I do have all the data for. It just takes some time to run that through. But you will notice that for all the regions, we're the top on all three elements: QPF, snow, and ice, and I mean almost perfect on QPF. Market improvement on ice accumulation. Snow amount had some improvement. I know there's more that can be done there. We had a few issues in the Great Lakes, but I mean, overall, really, really impressive. Just throwing a bunch on here. I probably should have done a little animation on for this one. Start from the top there with some verification when looking at WPC, because remember that the super blend that we had going into this year's experiment and what everybody had for across the region for super blend did not have WPC in it. So it was really interesting to see, okay, what happens? And so when you looked at those low to moderate precipitation events, consider them kind of like advisory or even going up into the somewhat of a warning situation. Super blend was as good or as better than what WPC had. But when you got to those higher end events, when you get up to the higher 1-inch QPF, 12-inch snowfall things, WPC performed a little better. And a lot of that, I mean, might be related to the fact that super blend, it's a blend. You're gonna knock out those heavier precip events. So I mean, that might be kind of a nice clue for us that when we you might have to pay more attention to those kind of situations. Go try and get the grids to reflect a little higher amount. But question mark is how much confidence do you have to put some of these heavier QPF amounts into it. The high wind events, we had some issues with the blended starting point, and that's a known problem, almost kind of similar to the QPF, but in this case, for the high wind, you've got the bias correction coming into play that kind of tends to temper things down a bit. And so I know a lot especially for the mountain ops is having to switch to using some of the statistical MOS guidance proved more fruitful there. Let's see here. And during the whole, of course, the experiment, there's been question marks. What's the target of opportunity? And the grid team actually asked them, kind of asked the consistency team, can you do something about, can we get something out on this? The grid team will continue to work in, and the consistency team did, and came up with this presentation that hopefully all of you have seen. I definitely recommend, if you haven't seen it, to go through the webinar about forecasting the ForecastBuilder era to try and address that, and kind of related that last bottom point about having these relatively meaningless adjustments. And it's I think that's being toned down. It's still out there to some degree, but it's definitely not, I think, as to the degree it was when we were in the beginning or middle of the experiment. Just looking at a little bit at that verification for QPF, WPC actually was nice and produced some of these graphs, and this is just QPF equitable threat score. And again, here you can see that when you were in those lower to medium kind of amounts, going up to like a half inch, that the NDFD here was proving pretty good there with that. But when you get up to the 1 inch, the WPC was a little bit better. So again, it's just, I think, a recognition that when you get the higher QPFs, here's actually a nice place where we could have some interaction with WPC. But it's not always the case. That can be, and that would be good either, which we showed in the February 25th snowfall event in the Midwest. Some challenges. The big one still remains, even here at my own office, maintaining super blend to be the same has been very difficult. There's a lot of reasons. You have AWIPS builds that are different from site to site, and each one you got to try and account for. put different statements into, okay, if you're on this build, you do this. If you're on this build, you do that. This build will break things. Then there's, getting in and decoding of model input data. That's both on the national smartness side and for getting it across, like if you have local data, like our Canadian model that's in there, that will, if you don't get the Canadian, you're going to have issues. And then local AWIPS configuration, keeping that all up to date. So, we've been closely watching, not just our region, other regions too. Been watching like super blend verification and comparing it with what the NBM has been coming up with, and the verification is on par, even in some cases better. And what's nice too, the NBM assures the common starting point. I mean, it's the one model coming across. There's not going to be any difference. So from the grid methodology team side, there's a strong desire to switch. However, there's still significant challenges that remain. This is true with SuperBlend and to some degree the NBM as well. What's nice is that as we were going through the experiment, we were continuously remaining in contact with the NBM developers to try and fix a lot of these problems that existed with the starting point. In the case for SuperBlend for us, and then the NBM, of course, on the national scale. A couple of graphs coming out of the surveys. On the left is just, hey, how long has it been taking you to create the forecast, and how would it compare to what you did before? And what is nice that you see is that as we go along through the winter and into this, even through the winter months, we definitely see an improvement of having a shorter period of time, which is what we, the grid, one of the, the grid team's 3 goals of increased consistency, increased accuracy, decreased time. That's nice to see the decrease there in time. And then the outcome of the produced weather grid for the, for those offices that you're using ForecastBuilder through the full version of producing the weather, definitely an increase in the positive responses. And hopefully, one of the things put in during the middle of the experiment was a faster production, and I think that also helped to increase the positive remarks. So if we head into the future here with for ForecastBuilder, some of you, or actually not some of you, hopefully most of you have seen some of what HazardBuilder provides. It's in the gets created again on the cron, and then again in the weather creation step. And when you go into the foundation grids step, it highlights all the grids that are highlights the different types of weather that you should be more paying attention to, things that are bigger significant impacts. So yeah, so like I say, it's already built in. There, I would expect a robust and training and demonstration package. I'll talk a little bit more on HazardBuilder here in a little bit, but what's going to be kind of neat here, what we're thinking in the future, is to combine it with like the model certainty procedure and maybe a few other things to help assess the problem of the day and provide, hone in on those targets of opportunity for each forecast. We'd also like to get all the entire region to a full and consistent version of ForecastBuilder. By the end of February, there were 29 out of the 38 offices already on the full, so just push it the rest of the way. And then also we've got digital aviation included within ForecastBuilder. There's still more that can be done in that regard to completely mimic, because digital aviation is probably like 80 to 90% of the way of what the current digital aviation procedures and tools have. So we're going to get that all the way through fire weather. There's stuff being worked on there because it would be nice to provide a consistent suite of fire weather services. All the grids being developed in the common way. Again, some of that's being worked on right now, so that's something to be looking forward to as we go ahead in time. Also, to start looking at the enhanced short-term forecast again more. We had that period there a couple years ago where we tried to get a focus back into the ESTF period. We kind of need to revitalize that and get that pushed more. We've got some time savings now from that period 3 on, and we really need to make sure that our beginning portion of the forecast is true to build that trust with our, with our partners and the public. As mentioned before, switch into the national blend as a common starting point. Definitely, ensures that consistent starting point that we're having a really hard time trying to keep up with the super blend. And then WPC is also planning to eventually start with the NBM. So, if we're all starting, that will help, at least in the collaboration process. And well, lastly here too, expanding ForecastBuilder out beyond just central region. That will not only help offices that are bordering other regions with collaboration issues, but it'll be nice as a whole. We'll be able to bring in other methods that other regions are using into the whole collective. Sharing, it's like a nice way to share forecaster knowledge across Weather Service, and Western regions already beginning to come on board with that. So, getting into some past weather here, this April 28th through May 1st, grabbed a couple of snapshots. This is that big flooding event that impacted both Springfield and St. Louis's area, and just thought I'd show, here's QPF forecast. I mean, consistency-wise, very impressive for that. In fact, the actual amounts are very similar to what WPC has as well in them, and some little higher amounts within the Missouri, but I mean, really very, very comparable forecasts. And then when you compare it to the observed precipitation, now there is some time difference between the two, but they're, relatively speaking, close. But I mean, if you wanted to do some comparisons back and forth, there's a little more QPF that was up in the Midwest because of this time difference. But same idea between these two. Thought that was really cool to see. On the snowfall side of this event, this is, I know, Goodlands area picked up a hefty amount of snow out of this. I think it was like 14, 16, 18 inches in that general realm. And here we go with the snowfall forecast. Actually, in this case, I think the WFOs did a little better job, and then this is the observed. At least, there for western Kansas, and there's the observed snow. So got the axis down, got some details in there. So again, I think just really, really, really nice. Shows what we can do now. We can produce much more consistent snow and ice than we had ever in the past. On the science tech front, prob ice present. I know we're going into the summer months for most of this. This is more looking now probably towards the fall. I happen to notice that only the testbed offices were producing prob ice present on cron. Back in January, when the prob ice present was put on cron, it was intentional to only put it to the testbeds because we want to make sure everything was okay. But then forgot to do it in the April update. Was fact hoping to actually get it in a March tech order, but we couldn't. That March tech order had to be delayed, so until April. Hopefully most of you know, and then NBM version 3 will be flown across the SBN July 11th. However, AWIPS in its current form will not be able to handle it. And additionally, there's going to be a lot more fields that are coming across. A lot of like the top-down grids that we currently use in the framework of ForecastBuilder, those won't happen until we do some changes to AWIPS. So the National Smart Unit team is working on prepping the AWIPS GFE for the NBM version 3. There's an AWIPS build 17.3.1. Right now we're in still, I think 17.1.1 being still installed at places. So it's 17.3.1 is still a ways up, at least until November. So we really want to get the stuff out for NBM out to everybody, so we can start looking at. Again, if you haven't, please start looking at that NBM EXP data set in GFE that's got all the a lot of the version 3 code. Snow level work is ongoing to be put into the top-down process, which will be especially helpful for mountain sites. What's also nice, talking about viewing the MBM EXP, the Central Region Mountain. Some of the mountain offices have already been looking at it and helped play a role in adjusting the MBM version 3 already to even after the code was checked in to get some of the snow level stuff to their satisfaction. So that was cool to see already going. There's analysis still ongoing with how to improve sleet and freeze and rain. One of the ideas been floated is possibility of replacing maybe property-free sleet with a negative energy low level, which is basically telling you how much area is encompassed in that low level cold dome on a sounding. You have a little more information. The only thing that have to keep in our mind is that, hey, we're going to modify the current process and we're going to summer. So anyway, there's analysis still going on in that arena. Probability of thunder. Now that we've gotten into May with quite a few even severe events out there, we've had a good chance to look at the probabilities of thunder coming out of like the SREF and that, and definitely, I mean, they're calibrated, they're lower than what we're used to. So, but I mean, they do a decent job at depicting the threat area from what I've been able to tell, and from feedback from others. So, how we might change ForecastBuilder, I'm still not sure on how to adapt to this. But I guess in the interim, one of the nice tools out there, I believe it's a baseline, not 100% positive, but there's that shrink stretch tool that can bring those values up to something that's more what's you might be used to seeing in the thunder. And then in this next update, we'll have an integrity check added to ensure that pop thunder is less than the pop, so you don't end up with definite thunder and chance of showers. Also, something being worked on here is to bring in a back button idea. I know that's been something everybody's been wanting. One of the people that's kind of assisting out here with the ForecastBuilder, Eric Wise, kind of came in some nice code to bring you the idea of go back to like the main menu, for example. Obviously, it's still not preferred to actually having a pseudo back button, but again, this is all kind of working within the normal GFE infrastructure coding for GUIs. We eventually have to move this out of the GFE infrastructure GUI coding and into a different coding framework, but that's a much more bigger process and involved to do that. HazardBuilder. Again, like I was saying earlier in the presentation, hopefully most of you have seen the output. And I know that there's been feedback, hey, can we have a pause at the end of the weather grid step? That will be there so that you can take a look at what the HazardBuilder grids look like after you ran the weather. What's really nice about HazardBuilder is that it fully integrates what's going on in your forecast as well as with what's in National Center forecast. There's some stuff that's brought in from WPC for some of the I think longer range flooding. There's stuff from SPC on some of the thunder stuff, and I'll actually show that on the next slide. So it makes it a great situational awareness tool, and in the future this could become a new even DSS service. So basically view what you see coming here out of HazardBuilder as nice target of opportunity. Grids highlight for you, bang, here's where you got to spend your time. And then expect a webinar, presentation, something like that, I think soon from the Central Region IDSS team, where they'll talk more on HazardBuilder and again, which has more application beyond, I think, the target of opportunity. So here's kind of example. I stole this from Wednesday when we were having a severe event coming in, and how go to the foundation grid step there, and you can see that the time periods that have been highlighted for some severe thunderstorms and wind and tornadoes. So I mean, obviously, I'm sure you've probably already been looking at it, that this period would be a concern for severe weather, but if not, it highlights that aspect for you. Other things are getting highlighted, like maybe there's a fire weather concern somewhere in your CWA, or frost freeze concerns. So, which that one little red there on frost freeze, we did end up issuing a frost advisory on. All right, Jerry, if you're on, you want to speak on the model certainty?
Sure, I can do that. So, along with the CR 17-08 tech note, the model certainty tool was installed. This is just a tool that can basically emulate what's going on in SuperBlend, but give you some information about the uncertainty within SuperBlend, and it will actually allow you to, based on that, certainty with the standard deviation, to select and deselect models and see what impact that has on the certainty of the distribution. So if you're feeling like there might be a sort of lone wolf model that could be bumping your temperatures way up, this would be a tool that you could use to sort of figure out that lone wolf. I have a link down here below that Andy can click on it. And basically, this link is a really quick, oh, he's got to log in. But it's a really quick way to get it. It's a two-page idea of what's going on with the model certainty tool. So, like it says here, the tool will give you the max, the min, the median, the average, the standard deviation, skew, and then the exceedance of the distribution. So you can go through and select any one of those models in the 2 and 3 column. Elements. Now, one interesting thing here is for the snow and QPF, it actually does a storm total. So if you select a period, it will give you the storm total from all those different elements over that period, and give you, sort of that distribution instead. You'll miss out on some of the, I think it's maybe the standard deviation. One of those two you'll lose out on, but you get all the other information there, the max, the min, and all that. Some more information about the skew. The skew is it's not like this typical skew definition, but it is a representation of skew. So we're taking the mean minus the median of the distribution, and then dividing that by the standard deviation to sort of normalize it. So if there's a positive skew, that means you have higher than average, or your average is higher than the median, and thus your guidance is increasing the mean. So basically you have some guidance that is pulling your average up. So that's just a really quick idea of what's going on with the model certainty tool. If anybody has any feedback, please send it along. It will also it has a highlighting feature. So if your standard deviation, like if you have values that from a model that are, or from your mean, that are more than 2 deviations away, then it will highlight those grids. So that's a way of sort of looking at this and seeing that you have some uncertainty going on.
We are currently improving an issue with your audio connection. Please stand by.
Are you hearing me?
I heard Jerry.
Everybody there?
Yeah, I'm here.
I'm here. I heard you fine, Jerry.
Oh, weird. Yeah, so I got some weird audio warning. But anyhow, I guess I'm done talking about model certainty, so Andy, you can continue along.
All right, thanks. And actually, this is a great point, because we are now at the end of the webinar. Does anybody have questions?
Andy, this is Chuck.
Yeah.
I don't have a question. I just wanted to provide some comments about the experiment itself and really express my appreciation and the appreciation for the team, for all the forecasters that participated, all the feedback we got. Really just the attitude that we received from the forecasters and adjusting to a lot of the things we were asking them to do, and it really was a positive experience for the. And we appreciate the great suggestions we received via feedback and all the comments and just the engagement that we had with the forecasters across the region. I think we had a lot of great ideas come out of that, and I think we made some improvements as we went along. It was a real effective process, and I just appreciate the effort that everybody put into that, and particularly the ITOs and GFE focal points, everybody that worked to try and keep up with what we were doing and the changes that we would implement as we wanted to put some suggestions into effect. And I really think that worked well throughout it all, even though we had a few bumps there. Overall, I think it worked real well. And I also want to mention that when we met with at the final day of our workshop up at Central Region headquarters, when we were developing the results and the findings from the experiment, we sat down with the regional director, Chris Strager, and I set about trying to explain all the things that we had found out about the experiment, all the great findings that we had, and basically he cut right to the chase there and went right to the bottom line and said what he loved about it was being able to stand up when he's briefing the head of the Weather Service, briefing Louis, and looking at our the Central Region grids, the forecast that's out there, and just seeing the seamlessness and the lack of CWA boundaries and geopolitical boundaries across our forecast. And big event after big event after big event, he was able to just sit back and point at what Central Region is forecasting and having it look really representative of what the weather probably was going to do that day. And it was really was the moment for him that he really saw the benefit of what we were trying to accomplish here. And that was his big takeaway, is having some pride there, knowing that his region was able to provide those seamless grids for these high impact weather events. And it was really made him proud to know that our region is able to step up and do that, and really on the national scene there. And when he's there briefing the Louis and the rest of the folks at the higher ups of the Weather Service. So that was his big notice of the experiment, and that was pretty gratifying too. But that all goes back to the forecasters and the effort that they've put into to maintain this, and the collaboration that takes effect as well, even after the common starting point. So it's just a process that at least throughout the winter seemed to work pretty well for the most part, and I just appreciate everybody's efforts for that. And yeah, we look forward to continuing the good work and seeing how we can even tweak it a little better as we head into October.
Thanks, Chuck. Yeah. Anybody got questions? I will say keep providing feedback both onto our onto our VLab site forum or directly the email. We're still making improvements. That requests had one just recently, and was very simple to take care of. Frost over the lake. Easy to have happen, but I got modified that. So.
Well, very good. Well, Andy, Chuck, and Jerry, and thanks so much. Did a lot of really great work here and continue to. And thank you to everybody for their consistency in the forecast, which was noted, as was said, and also the cooperation. Really, that was noticed and appreciated. Okay. Well, just wish everyone a good weekend, whether you're working a shift or not. And if you are, thank you for doing that. And take care of yourselves. Bye-bye.